Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Once again, my name is John Sangiovanni. I'm a program manager in the University Relations team at MSR. And some of you I recognize were here for Ken's talk this morning. This talk is going to be a little bit more of a deep dive. So Ken's talk this morning was really a broad brush overview of a bunch of the cool projects that are happening at his lab. And then today we're going to be able to dive a little bit deeper into Rapunsel and Creole. Ken and I have been working together for several years. Ken is a researcher in multimedia and graphics and other things. We've been working together on gestural text input systems as well as zooming user interfaces for tablet PC. Ken is the recipient of the Presidential Young Investigator Award from NSF, as well as multiple other awards, including a Technical Achievement Academy Award for his work with noise algorithms, and has recently been a featured artist at the Whitney Museum for American Art. And actually, Ken has been here several times for several talks, but this time we're happy to also have Mary Flanagan, who is a professor at Hunter College and also actually has been featured at the Whitney Museum as well as the Guggenheim, and her work has been featured at SIGGRAPH and Ars Electronica. And her description is very accurate in the sense that Mary is an innovator and an activist and also a designer, and has a lot of really interesting insight on technology culture. So between the two of them, I think you'll agree that it should be a really interesting talk. We're going to structure it as we typically do, where we're going to have an overview of the project over the course of the next hour, and then we should have plenty of time for Q&A at the end. So please join me in welcoming them both.
Well, thank you. I think that I will go first. Ken and I work together in this very interesting way, and so part of our presentation will probably be an exploration of our collaboration in live dynamic interrupt mode. but be that as it may, wait, but you forgot, which is how we work. So what I'm going to start off, and I'm going to talk about the history and a little bit of the background on the Rapunsel project, which, as you can see, is a really I like to just say real-time applied programming for underrepresented students, early literacy, really fast, so that we can get the long title out of the way, and really delve into some of the issues in terms of design goals, hypotheses, these kinds of things, and where we are in our process. Show you some demos, and then really chart how the process is really affecting other kinds of system thinking, like thinking about processes and art and science collaborations in general, and then also how this project is spawning a whole bunch of other related kinds of projects, including CREOL, which is an investigation into the actual kind of cognitive act and linguistic act of programming. Okay, so that's what we're going to do right now. So the motivation for the project, Ken mentioned earlier this morning that 7% of practicing programmers are women. This figure changes depending on who you really talk to. National Science Foundation is talking 7%. I've read as high as 25% on some independent sources, so it just depends on what your source is and how you're defining practicing programmers. But I think we can all agree, whether it's 20% or 7%, that there is a lack of women in engineering and technical fields, especially programming. And one of the things I think is really interesting coming up with this project in general, I've done gender research in technology for several years. It's very interesting to me because sometimes there's a backlash about why women should be involved in programming anyway, why women should be kind of involved. I was giving a talk at the IT University in Copenhagen, and several people in the audience just stood up and said, this isn't, maybe programming just isn't for women. This is not something that women should do. Women are not inclined to do this. And I said, I just can't agree. I just can't agree with that, based on my own history as someone who's interested in art and technology, and as far as research goes, and as far as lots of other examples. So I'm really, but to answer that question in depth is like, in what kind of cultural context can women get engaged in programming? Why programming specifically as an activity? What about programming is particular to our concern? And then and how that can translate into other kinds of environments. So that's kind of big picture. For me, a personal motivator, when I learned about computing and technology, I came at it from a film background. I'm trained as a filmmaker, and I learned a lot of the computing stuff I know from animation. So, you know, when you had the PDP-11 and you could do rotoscoping on this like, thing, you know, and do some sketches on these really crazy systems, you know, you had to program to actually go from frame to frame. You had to do these kinds of things. And so that's how I got into this kind of stuff. And I think for both Ken and I in our various backgrounds, the idea that somehow the ability to author and the ability to have a voice and to be able to tell stories and to be able to just, whether you want to model or simulate a system or you want to just kind of share an idea with a friend, more and more that kind of ability relies on an ability to program. So I think that that's a kind of a core question for us. For me, the other thing is I really feel it's important to have diversity in the people who make the tools that we use. If we don't have, I'm really happy to teach at Hunter College right now in New York City because we have 70% of the student body is people of color, of some kind of cultural ethnicity other than Caucasian. And it's really interesting to have really diverse classrooms. I used to teach in the Pacific Northwest, and it was a very different experience. And I think that this idea of diversity brings a whole range of voices and ways of thinking about all kinds of tools and technologies. And that's not even, then we're still in an American context, in the U.S. context. If we have a global context of people coming from a variety of places and having an ability to author, I think we'll see our tools really dramatically shift in terms of what they can do and surprise us. So that's kind of my motivation and his too, pretty much. Pretty much. Yeah, just nod. Okay. Okay. So just you may be familiar with these figures, and I don't want to bore you too much with them. But women in computer science, it's a big deal. It has to do specifically with our project. Right now, we do not have any computer science women working on our project, graduate students. So that's an issue that I think that we as a team are working on. We have undergraduates and I have design graduate students. We have a lot of different kinds of people creating the team, but the actual technical people who are sitting down to code are not females on this project so far. That's something as a design challenge, like it's a really we're very conscious of it, and we're very much trying to figure out how to negotiate that because it is a reality. How can we shift that? How can we bring in outside people? How can we get a lot of input? But these are just some figures. 37% of the bachelor's degree in computer science in 1984 and 20% in 1996. So the numbers are actually going down for women graduating in computer science. And the game industry, if you went to the GDC, you would probably notice that there weren't that many women. Some charts. This is National Science Foundation stuff, just showing the number of women dropping. I just think it's good to have this context. Here are some research questions about research. How do we best research gender issues in gameplay and online experiences without creating more stereotypes? Because one of the biggest concerns when we talk about gender in computing is this idea of stereotyping our users. How, you know, what is a girls? You're making something for girls. What girls? How are you defining the target? And the broader the sweep, the more stereotyping we're subject to. How do we make games and online experiences that appeal to women and girls? And how can we, through making these things and experiences, diversify these technical fields? So here's some initial ideas and proposals. We're very inspired by The Sims. I've written a lot about The Sims, and I really like sim abuse. It's really mean. But beyond that, almost any child will play a computer game without help. And one of the things that is a fundamental motivating thing for us is if we sit down and sit a kid in front of Logo or sit a kid in front of Squeak, and often these things, these are really successful teaching programming pedagogical missions in a lot of ways, but there are some fundamental flaws, and one is you need an adult to really sit down with you and learn this stuff. Two, a lot of college students, when I ask them, have you ever programmed, they'll say no. And then I find out that, you know, later in the semester that they spent 5 years in an after-school program doing Logo. And so the idea that Ken mentioned earlier about people sometimes don't even know they're programming and they're programming, that's an interesting thing. But it really affects, it's important because when you talk to women or underrepresented groups, you have people who don't have a high confidence in their abilities to compete in that area. And if you can't own up to any kind of expertise in programming, you may not be letting yourself go further in that field. You may do some self-limiting. Anyway, after-school programs are a really big problem, and they rely on a lot of people. We just don't have a lot of people, especially in urban schools. Kids must be stuck on the bus at this time. They must lock the school. I don't know if any of you have worked with schools, but it's very difficult to really, public schools, it's very difficult to get 5 minutes of time with kids. And so after school seems very difficult. So, and then just here's some figures about online gaming experiences. Half of all computer games are purchased by women, says the IDSA, and 60% of the online players of The Sims online are women. So there's a high interest in multi-user online game experiences and game experiences overall. So that is part of what we're thinking about. We did a survey of a lot of different groups of girls, our design partners, and we, EverQuest, Sims, Harry Potter, Neopets, very popular games for girls. Pikmin, I may have spelled that wrong. Is there a K in Pikmin? Okay. I feel like it. Okay. Animal Crossing, and then Moose Crossing, Brenda Laurel's work, Nancy Drew, which is written on the road somewhere, I think. And very popular computer games with girls, and of course, the mysterious, I challenge you all to investigate solitaire, because this is like the holy grail. If somebody in this room can figure out, this came up earlier at your talk, and it is the holy grail. If you can figure this out, let's have dinner, or at least help me figure this out. We can figure it out together. Okay, so our target audience, 11 to 13-year-old girls. Statistics show that in math and science, boys and girls have similar test scores until middle school, and girls' test scores start to go down when they hit 11, 12. We're talking 5th, 6th, 7th grade. And the test, this has been going on for a long time, and it's not just in the United States, it's also in Australia and the UK. Those figures I found quite easily. Of course, this is a critical age because this determines what you take in high school and all of these kinds of things in math and science. And it's a critical age to learn programming because this is when you may sign up for that class, if there is a class in your high school on computers, and also where you're starting to do a lot of computer gaming. So it's a very important age, and we want to affect the target audience if we can build confidence and if we can make a fun environment where kids can play this kind of stuff. It's very important. So just a little of my prior work before I started working with Ken. I did a online game for girls called The Adventures of Josie True, and it was funded by the National Science Foundation. It was the first online adventure game for girls. It was all done in Flash, and it was really designed at a 5th grade level to boost kids' confidence in math and science curricular areas. So things that they may have already known how to do, like do pulleys, these kinds of things I put together in a design with 14 different game activities that were contextualized in this time travel adventure thing. And I'll just show you some screen grabs. One of the big things that came out of this project and also from existing research was role models. Bessie Coleman was this African-American aviator, and she is kind of one of the heroes that you meet when you travel through time, and you go in cloud seed with her. And this is her, Josie, she's a character there. Her science teacher, Ms. Trombone, travels in time and is an adventurer, and basically has the house that I want to have if I were a cartoon character. We end up in the subway with these thieves. We're chasing people. We meet Marie Curie, and she's glowing. Okay, anyway. So there's all this stuff. This is something I did with my students when I was teaching at SUNY Buffalo, and I learned a lot from the project, and it seems to be a real success. It's total grassroots marketing, stuck on the web, giving it away. Here's some results, though. In some of the prior studies that we did actually find that girls scored a little bit higher in math and science activities. For example, division, or like division problems in a game, division problems on a web form. The girls actually did score a little higher, and I could only hypothesize that it's because of the way that the girls received feedback, that there was this motivational context. I think that's got to be what it is. But there's one problem that came very clearly out of that process, and the girls would say, "Well, I want to make my own game." And so I was like, uh-oh, how do I do that? And then we started working together. Okay, so So that's a big question, is how, I started to feel really manipulative. This is why I no longer make films. Like, because you put someone in front of something and you have it's a very controlled environment. And I really like the idea of opening up some kind of environment enough so people can have their own authorship. It's really not authorship to play a game in which you're following someone else's choices and things like this. So how can you really somehow create in a shared space like a game? Okay, so we have some major goals: learning math and science principles, and figuring out how to motivate girls, the self-teaching idea. The idea of a social community. One of the biggest things that comes up, of course, when you're designing for a target audience is, what are they already doing? Many kids are at school, they come home. If they have a computer at home or their friend's house, they get online and they chat with the friends they were just in school with for the next, 4 hours. So, do you laugh out of, it's true, yes. Yes? You do it too?
Underprivileged minorities, they're unlikely to have broadband internet, so if the computer has got the phone,
right, it's true. 54% of American households, as of last year, I think, are wired for the internet at home, which is, I was shocked at that high number. Anyway, I must move on, but also these after-school clubhouse places was some place that we've been talking to, and I think that would help parents. These larger goals, I have to show you demos. But we're evolving to a culture that focuses on this idea of authorship and instigating larger social change. And this idea of multiple means for success comes out in a lot of different ways. And this comes out in watching kids play The Sims. Some people want to play The Sims and build houses for 6 hours. And some people want to, set the house on fire. And some people want to. So this idea of multiple rewards and multiple game goals is really important. Okay. So let me just skip over these things here a little bit. So the approach is to what we're doing right now. We're in year 1 of a 3-year project. It's a National Science Foundation funded project. And in year 1, we did a lot of sketches and demos. And we also we started these relationships with the Intel computer clubhouses. And so what we do is we go every couple of weeks and hang out with, middle school girls, and if we have stuff for them to play with or show, they'll give us feedback on it. We ask them questions about what they like to play. We show them different pictures, and what we're doing now is storyboarding out a whole bunch of ideas to get their feedback before we do some implementation. We really jumped quickly into implementation when we first started to do a lot of little demos, and now we're going back to the drawing board with some of the stuff that we've learned from there and doing storyboards. Another part of this, just investigation really quick, is this idea of VID, values in design. I don't know how many of you really think about or know of that field. About it feels like a new field about figuring out how designers infuse values into the products that they make, and how we reproduce values perhaps in the products that we make, and how we can identify that as people who make cultural artifacts. So like reflecting on process, like as a designer, I have a gut reaction to think, oh, this is the right idea, this is a killer app, I know it, that thing, and then to try to pull back from that and also say, well, where are those assumptions coming from? And I'm as constructed by the culture that created me as well. So how can I look at my place as a designer and say, okay, maybe. What if maybe I should come up with 3 of these things and run them by people? I mean, you get the idea of balancing, user input and outside feedback and the tension of the designer, something we were talking about earlier, but it's a very interesting tension. But these test beds are very important for us to get real feedback. So the team, there's 3 principal investigators, myself, Ken, and Andrea Hollingshead, who's a social psychologist, and each of us have kind of split up our roles, although we bounce back and forth. We have these game design, animation design, and assessment and measurement tasks. And I'll talk about my tasks really quick first, which are like thinking about how the world can be a public and private world, how others are represented, how to appeal to many kinds of players, and these ideas of time scenarios. A lot of the girls like to play Grand Theft Auto that we're talking to. A lot of them. And I So one of our hypotheses, or one of the things that we're thinking about is, well, maybe it's because they have, and it's actually coming up on one of our larger official tests, is to see if they have older siblings who play Grand Theft Auto in the home, or how they get exposed to these things in the first place. But really, they're like, they want to, yeah. But one of my ideas about this is maybe it's also because you have such a freedom to do what you want. Like some girls will say, I just drive for 3 hours. You know, so they don't necessarily have to whack the prostitutes over the head with a baseball bat if they don't want to. They can do other things, and so that's interesting to me. Like, and part of it does seem to me to be a sense about time somehow, a sense of tempo. Anyway, we'll get to that. Chat. Okay, so I want to show you some interface design, some early sketches done by the team. Here's just like interfaces about building up a personality for a character. We get a lot of feedback that we started with these little poly characters, which are these little kind of cube here, these little polygon things. You see them? As our characters, in part because we didn't want to try to measure up to something like The Sims, and in part because Ken had made them already, and people love these little things. And I'll show you some pictures of them doing their thing. Here they are. They're still, and this is an initial mock-up of what the system looks like. And here people are actually trying to program this interaction between, like this one gives a ball to the other characters, and they have like there's a chat screen so kids can copy and paste code back and forth with each other, and then they can code. This is an initial mock-up. You notice that this is Java, and we did one test where we exposed kids to Java in the lab about 3 months ago, and we asked kids to change properties, just cold, without any scaffolding. Just showed them a whole bunch of code and said, okay, make the ball red, make the ball blue. You know, gave them specific missions just to see if what would happen when faced with this. And you know what the biggest problem they had with this screen was? The word code. They're like, what is that? What does code mean? And they didn't care. They could change the color, no problem. But they looked up the one color, they changed it out. It was not so I was like, whoa. So this is all part of this process of very interesting. I did not expect that to happen. Okay, I have to go back. Okay. And here's some other, like one of the things we want to make sure that we do is when we're designing what this code window looks like, we want to keep the metaphor consistent, keeping the metaphor. So we have one of the things, we have like continuous code in a book. Here's like little textbooks filled with code. We have sketches where the team has created like hallway lockers that pop out different pieces of code that if you're like running around, you can find your way. Gardens where you exchange seeds, and the seeds grow into little pieces of code, which is my favorite thing. Anyway, and then I'll show you just some quick storyboards before I show you the demos.
I just wanted to mention something here.
Rock on.
All right. One of the things that may not be obvious if you're working with a bunch of computer science graduate students, the hardest thing in the world is to convince them to work with paper design and storyboard things, because they just want to say, I just want to program it, just let me program it. And then once you actually force them to go draw things on paper and like work out the ideas first, they're really happy that they did, but it's not the way they've been raised, right word?
Yeah, and one thing I want to say two things about the kind of disciplinary shift in between computer science and art and design, whatever discipline I'm in. I don't know what it's called really, but one is that he thinks very specifically about problem solving, and I think very big picture, and then we pass, and we meet here. Generally, hopefully.
Well, we often find we're talking about the same thing.
We talk about exactly the same thing.
But it takes us a while.
Yes, it takes us a while, and it's different than industry collaborations I've had before. It's very interesting. And the other one is that we're doing research in an academic context, so things like in computer science, working alone is really kind of the way to go. It's not like software engineering in the computer science field really isn't taught in the same way that you would have to do it as a professional. Keeping track of things, and so there tends to be a lot of, okay, I'll go over here, and then surprise everyone, and it's like, well, okay, let's iterate that. Let's work together. Let's, and so there's a lot of those kinds of process things, which really are a challenge. And so in fact, we have gotten very far in our research in the first year, and we went backwards because we wanted to start throwing out. We wanted to be sure that we weren't going down. We had that little prototype with the code and the chat window. All that was working demo. Everything was fine. And we realized if we didn't have the breadth of ideas to work with the kids, we would be walking down a road where we're just like following a gut and implementing and not paying attention to any, what the real issue is here of like diversity in the field. So it's very cool. Yes? You have more? I'm going to show more demo. Okay, so I want to show you some of Ken's cute animation things. And I don't say that just because he's here. Here are the polys. This is an initial a poly. I feel weird showing it when you're right here. Like, normally you would show this.
Go for it.
Okay, I'll show. Here are the polys. Okay, so I'm going to just have this poly move around. I'm going to have the poly soon move. I am on a Mac. Okay, so this poly is dejected, right? The poly is dejected. I have said something nasty to the poly. Haven't I? Now the poly says, no, you have not. And I say, oh, really? And then, this is my favorite, and now it says yes. Okay, good. So we have the poly sprint. Whee! And then the poly can have hot feet. Ow, 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 ow. Ow, 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 ow. So, I can make the, yes, that's right. Okay, so I'll put the poly on broad jump and have it just jump around. So this is just this was the kind of starting point where everyone who sees these little characters, they have no eyeballs, they have no, they have really no arms. How can you have a simulation game with these? But in fact, this is what we started with, and they seem to be really popular. If you ask girls, would you rather have these or humans, they'll say humans. But when they're just playing with these, they actually really like them. So there's a very interesting dichotomy that happens with them. But I want to show you some more. Where are your, here we go. Here are two polys working together in a little space. Okay. So this one, I might get to hop, and this one, I might get to, remember, I'm on a Mac. Whoa! Did it eat it?
You scared them.
Wow.
They never run away.
Wow, I even turned the world bit. I know, well, okay. So these are, here's the Ken in his spare time decided to make poly chess. Other kinds of things like this. I'll just really briefly go through these. I'm going to show you the tag demo. Here's some polypath planning, so they don't run into each other. Do you want to say anything about any of these before I?
Yeah, this is just showing that they can all work together as a group and run around in big crowds, and like the world itself has enough intelligence in it so that you can take them out in complex environments, and they're going to do things like figure out how to walk past each other. So that's an example of the sorts of group dynamics that we want to build in so that by the time the girls are doing their stuff, the world is just doing the right thing without things that break the illusion of realism, like characters shouldn't just walk through each other.
And this is your...
That's the Harry Potter tie-in, which, you need. Yeah.
So that part. Okay. And then assessment. So we're doing informal and formal assessment, but here are some of the assessment questions. What game interaction and game goals motivate girls? The social status and family and play context, like, are the older brothers playing Grand Theft Auto? Are you going to be ridiculed if we're using a gardening metaphor and you live in, housing projects? These are very kind of important questions. And then how the scaffolding is really we're thinking about scaffolding really differently. A lot of times when you look at something like Squeak, when you start to move things, you move them, go forward 5. You build the Squeak example is always, you build a car, you go forward 5, turn left, or you build a drawing tool that has a loop, or these kinds of things. And we're trying to not necessarily just do things on a spatial or geographically located thing. And I think really looking at trying to code behavior, even though it's a much more complex thing, it seems much more socially motivated. So if you can say, well, this character's happy, this character's sad, that kind of exchange, if they have to exchange something in between them and there's mood involved, that seems like a much more tricky thing to scaffold, but something that we find very important. And even how the world is perceived. You saw the polys. A lot of the kids, when we just talked to them about the polys, we were very careful to not name them gender-specific names like Harry and Bill or Susie or whatever, and the kids always refer to them, and the team accidentally, even amongst ourselves, always call them he. So that's another thing, that they're perceived as he's, which so we're designing a little online survey tool where we're going to have different shapes, this degree of curve, and see if there's any kind of relationship between these.
You're going to discuss Arthur?
No. You want to discuss Arthur?
We had this one. He's just amazing. We explained, we want it to be something like what would be interesting to girls, and let's engage this question, and let's make storyboards, and this guy comes in, he says, okay, it's a truck race, and a truck smashes into the other truck, and it's monster trucks.
I've never seen anything
everyone's
like
just
this
looking
in my
at
life,
him.
really.
Okay, that's maybe, okay.
And he's like, I'm going to be honest, I'm not dealing with this whole what girls like thing. It's pretty clear.
I mean, he's honest.
He's very honest, and in fact, there was a thing that we could pull from his research. But the first one was about, I asked the guys to go out.
Killing the bird, right?
Yeah. Okay, yeah. The farmers smack. I said, go out and make a construction game where you have to make a bird. Thinking along the lines of Legos or some kind of construction where you have these elements. One of our game models is where you have all these elements running around. You have to collect a base and collect an armature, and you add a potion to make it fly or add a potion to make it crawl. So and then you can exchange potions with your friends as these behaviors that are code packaged behavior potion things. And he went out and storyboarded this farmer sees a bird and just whacks it and smashes it into a million pieces, and you have to put it back together. In a certain time period, or it's dead forever.
Because girls really like that.
To give him a man who said that. That was really good. Oh my God. Okay. Well, this does pop up though. There is one that secretly I did like his ideas though, because I'm going to jump out of my list. These are all things things that are popping up right now. We haven't done the full-scale assessment on an actual demo yet. We're still doing the pre-test and in the school setting. But we have meet with these design partners, and some of the emerging themes I just think are really fascinating. I find that I used to work across the street from Girl Games in Austin. I was at Human Code, this company, software developer, in Austin, and Girl Games was across the street. And I remember talking to some of the people there, and they were making these very girl magazine types of CD-ROMs, interactive CD-ROMs. Let's talk about me, where there's a horoscope and a genie and a clothing game and these kinds of stereotypical things, and they did a lot of research, and that's what girls reported that they wanted. And it's true, they really did say they wanted those things. I'm really fascinated by that. Most of that is not coming out, and it must be either it's because we're in New York, because we are dealing with a particular population, underrepresented, underprivileged girls. All the girls are girls of color who we've been working with as design partners, and most are from low income. Yeah?
They all play GTA. Why is it so bad about Monster Truck Race? I think that's a pacifist game compared with GTA.
Maybe if you could just sort of drive off the way. I'm not against the passive. I mean, if we're going to have a truck race or garden, maybe the girls would pick the truck race over the garden, but we'll see. But here's some emerging themes. None of the girls have mentioned shopping or these kinds of stereotypes. In fact, when they say the thing that they say they like least about The Sims is that you can run out of money, and sometimes you don't have enough power to do anything. So there's this idea that the whole economy they just want to avoid in general. And then this existing games, negotiating friendships and enemies, trying to make a right choice to negotiate social situations with friends and enemies. Very interesting. And the most popular game idea, which we really didn't want to produce, but we threw it in there in one of our pieces anyway, was this hero game called Justice Polly. And one of my students actually came up with this idea where, like, you're this judge, this little Polly is a judge, and she can go around and, like, make decisions, and, like, if there's a fight, she gets to fix every decision, and she's got a gun, and she's just, like, you know, boss, and she runs around and, like, has control. And of course, like, this was, like, very popular with the kids. So then you're like, oh, as a designer, looking at that values and design thing I mentioned earlier, it's like, okay, so how much am I giving kids what they want? A, because they want it. 2, because they're culturally reproducing what they're told they want. Or B, because I don't want to give it to them because I want to break a stereotype that, you know, what right do I have to impose another stereotype based on their existing stereotype? So there's a lot of tension, but I still think there's a way to work around it by figuring out maybe with these potions you give people properties of hero. You know, you can turn invisible, or you can fly, or do these other things with your characters, and still not necessarily have to have a gun to do all those fun things. And you can, you know, spontaneously combust. But this idea also that subversion, when it's okay to be bad, that's the one thing about Arthur's ideas that were really quite good, is that people do want to figure out ways to subvert their systems, and I think we have to I relish and expect those kinds of subversions to happen. Okay, and pair programming has a lot to do with the way that we've been thinking about this too, in terms of some of the design issues. Now, I just 2 demos, and then I'll give it over to Ken. Oh, this is kind of a response. This kind of not a cause and effect thing that happened, but one of the things that came up. You want to censor her?
Yeah, sure. You go ahead and talk.
One of the things that came up was building these characters, building parts like little bots, and we came up with this idea of seeing iBots, where you're in this neighborhood and people have various problems or needs, and so you have to come up and invent little helper technologies to assist people. And so, and we were also, Ken was also perhaps reacting to the fact that the Pollys were always perceived as male. I don't know if it's just because it's pink or what, but it tends to be perceived as a female character. So one of the ideas is that the self-balancing unicycle character could be like a seeing iBot for someone who is visually impaired in a neighborhood, and this can go, you can program it to go and pick up things or do tasks.
Yeah, the truth is I wanted to make a self-balancing unicycle, and I found it was way too hard.
Right.
So I just made a character.
But you were in the context of this project.
Okay, yes, that's true. And it was because I was in the context of this project that I did this, yes. Actually, you should close that so the next one is more efficient.
Okay, I'm just going to show one more after this. Okay, so we're in this testing mode, and one of the biggest things that's come up with the code is, of course, watching those trigger words is a big deal, but also never letting people get lost. So it's very important. Some of the code windows that we've tried, you know, like have a callback or something, and there's a particular little piece of code right in the middle of a game, and kids don't know where that comes from or how it relates to something else. So it's very important to have the code in always some kind of graphic visual context with the other pieces of code. And then this idea of how does our process, you know, how is our process really really affecting this stuff? Even the language that we use, like that code idea, also like when you say enter or submit, like all these words of power, it's just, I know it seems little, but they're kind of large things. You know, like make it so. So we changed all of our buttons to say make it so instead of submit. Because we, you know, these are little things, but they mean a lot, and I mean, they produce a culture. So anyway, and then maybe at dinner I could talk about business models of this, like dual bottom line business models and other kinds of ways that we can talk about values and design. And I have to show one more demo though. Okay. This is just a little tag demo that was should be coming. It's at Rapunsel.org is the website. Eh? That's good.
Okay.
Here they are.
Should we mention that thing about the engineering practice with the juggle and Java.
Go ahead.
Yeah, so we prototype everything with our own homegrown software renderer, which is all Java 1.1 compatible, so it runs on all the browsers, and it's all software that runs without any plugins. But then we make everything compatible with, now this is actually the same exact applet, but then we say, okay, run with Juggle. So the idea, which is, they have to load an 8 megabyte download. So the idea is that they can see whether they want it, and they can play everything, and then once they make the decision, they know what's going on, then they can download the big download. Because we're afraid if we force people to download a binary, especially in something over the web, before they've seen anything, we're going to lose a lot of the kids who might be curious.
Okay, so this is the little glowing thing which is chasing me. Ah! It's just tagged me, and now I'm it. And that's me. I have the circle under me, and I am chasing. The next version of this, one idea for this is to tag the player who has a little piece of code. One also thing that came up was about this idea of kids wanting to learn about other cultures and learn other languages. And so I was thinking, well, what if all the characters just spoke Java, which is a huge text bubbles, which is so it's a logistical problem, and it also is like, well, do you say print line, or, like, well, how do they actually? But if by talking to someone you can exchange code, like literally like a conversation, that's another model that we've been thinking about doing. But I think my time is up, and I have to share my time of talking with my collaborator Ken, who now is going to have his computer switched on.
Okay, great.
Thank you.
That's good. Okay. Yay. All right. So we're also going to probably have other characters that speak C#. So
We haven't talked about that.
Because we're a multicultural project. All right. So our next project, in the course of doing this, we started asking larger questions about societal transformation. And actually, at some point, I actually picked up this book. Let's see. Do I have it here? Oh, did I leave it? Which was really, how many people have read this book? Steven Pinker, The Language Instinct. Yeah, right. Really amazing. 1994 is the first one he wrote that started off all that stuff. Where he turned Chomsky into English and all that stuff. But basically once you read that and you start thinking about language, you start thinking bigger, And so we started thinking in terms of the following long-term goals. In another generation, like 20 years from now, 30 years from now, everybody in society should know how to program, like everybody. And nobody should ever have to learn how to program. I mean, it's really, in some sense, a fundamental goal that we'd all like, but how would we do such a thing? Well, the key is, if you actually believe research that's been done over the last few decades by nativist linguists, kids are linguistic geniuses. Kids are not like us. We are language acquisition engines from the time we're born until for the first 7 years of life, and then it sort of tapers off. In fact, different things in different years. For example, around age 3, kids are learning on the average of a word every 2 hours. And then at different ages, they're learning other things really, really well. And actually, they have different structures in their brains that kind of go away a bit after they get older. And there's plenty of historical precedent for this. For example, there are a number of cases. This happened in the 1890s in Hawaii, where you had rich plantation owners who gathered migrant workers from all over the world, and they couldn't really speak to each other, so they did what migrant workers do in these situations. They created a pidgin, which is sort of a toy language. Me, you talk, or I see it, and and it just and you couldn't quite tell what the other person meant, because you didn't have the prepositions, you didn't have the word order, you had mixes of words from different languages, you had to point a lot. And what happened in that case, which happens consistently when this happens, is that after a few years, these people started having children. When the children got to be about 3 or 4 or 5, then spontaneously, these little children, all collectively, without even trying, converted the pidgin into something that's technically called a creole. They made a new language, and they all rigidly enforced that language without thinking about it. So all the children ended up speaking the same language. And when linguists came later and examined these children much later in life, in the mid part of this century, in 1960s, 1970s, what they discovered was that the Creole, which came out of nowhere, came out of a melange of all these different pieces of our languages, was as sophisticated and advanced as any modern language, English or French or Latin or anything, which basically is a restatement of what we've learned over and over again. It happened with Nicaraguan Sign Language, which was spontaneously formed by one generation of children. Children invent language. Grown-ups don't invent language. In fact, anytime we try to introduce anything into a language, some slang form, etc., the next generation of little children act as a filter. And if it's not learnable by them, it doesn't last to the next generation. So languages don't advance forward. They kind of migrate sideways because now we've biologically advanced over the last 2 million years or so, which is, they know about 2 million years because that's when the brain started getting bigger. So what's a natural language? Well, computer languages are not natural languages. A natural language is, quote, learnable. Learnable means that essentially 100% of children end up acquiring it. This is in contrast to, for example, written English is not learnable. You actually have to teach kids. You have to sit them down and work with them, even though you think it would be easier, but it's not. They all learn to speak, but if you don't teach them to read, most of them don't learn to read. Mathematics is what you might call an adult language. Just as the kids' natural language abilities are fading away, they're starting to get really good at math. You know, when you're 8, 9, 10, that's when those skills are starting to kick in. Little kids aren't really very good at math compared with us. Programming is an adult language. But we can piggyback on the fact that English language, written language, is being already taught universally, so we can use that. So things to know about natural language. And I'm getting this from Steven Pinker's book, which is a great collection of a lot of the research that's been done since Chomsky. Computer languages are context-free. When you see a phrase in a computer, like a statement in computer language, you know, and they're deliberately designed this way, so you know what's the equivalent of a noun, what's the verb, what's the variable, what's the assignment, what's the conditional. There's no question about it. Natural languages are all of them, in every country you look at, you know, through all of the records we have, are context sensitive. In a particular sentence, you don't know enough to know what's going on. For example, a simple phrase, this linguists like to use this one: time flies like an arrow. Fruit flies like a banana. And so there's it's a very typical example of, gee, the noun and the verb and everything changed because, of course, we had cultural context. We knew what was going on. And little kids can parse really, really complex parse trees. If you built the parse tree, here, kids can parse this. Daddy trudges upstairs to Junior's bedroom to read him a bedtime story. Junior spots the book, scowls, and asks, "Daddy, what did you bring that book that I don't want to be read to up for?" And little kids just get that. That ends in 5 prepositions, which means that if you do the parse tree, different parts of that sentence, something is nested 5 deep. We don't have any problem with that. That doesn't mean we don't have any problem with anything that's nested. It means there's a certain subset of things that are parsed. Now, this is actually really crucial. It's the fact that you have these nestings and these large distances between matching things in a sentence that tell us that natural language is linguistic, that it forms basically Turing equivalent parse trees. You know, you have the equivalent of a stack, and you have nesting, and it's not a they're not finite machines, but only certain types of nesting. For example, things that are hard to parse, even though they're, quote, grammatically correct. The dog, the stick, the fire, burned, beat, bit the cat. If it rains, it pours, I get depressed, I should get help. People find it very difficult to understand such sentences, which is why you don't usually hear people say these sentences. Now, why are these difficult? Well, things that are easy to parse, by contrast, will show you. The policies that the students I know object to most strenuously are those pertaining to smoking. The woman who the janitor we just hired hit on is very pretty. So those are also nested 3 deep, but we have no problem with those. What's the difference? Well, it's the kind of nesting. If you take that first sentence and you change it to "the cat was bitten by the dog that was beaten by the stick that was burned by the fire," everybody in this room gets that. And we learned whatever we needed to learn as little kids to get that. Nobody taught us that. It conforms to things that we do natively as little kids that allow us to parse these structures. Incidentally, a useful thing to say at this point is that if, for whatever reason, a child is not exposed to natural language in their first 7 years, let's say they were raised by sociopaths or whatever, there are cases of this, they never learn proper grammar. And no matter how smart they are, you can't teach someone who's never learned any natural language how to speak, and can do lots of other things, but they're always getting that wrong. Although once you learn one, you can learn others as a grown-up. So it depends on the kind of nesting. This is a really small subset of a whole large field of what it is that's learnable by kids. And I'm only picking an example that I could describe easily, but I could spend weeks describing these things. So if we transform this first sentence into, 3 nested ifs, if, it, raining, pouring, depressed, need help, and we change the if A-B to B if A, which you're allowed to do in English. So we do a transformation for this, and he said, I should get help if I get depressed, if it pours whenever it rains, which we all understand. So the key here is that we can't nest the same token that's recursively buried inside itself. In those other expressions that you did understand, the nesting was different types of tokens. There was an if, there was a while, there was a whatever, and we can actually remember basically one of each type, and then nest them about 3 or 5 deep without having any problems. So there are particular mechanisms that we have which don't actually map exactly to the way computer parsers are built. Oops, did I skip over something? Hold on. One thing that is really important here to remember is to think about. I showed you the thing about the little kid and the daddy and the trudging upstairs. Everybody in this room can read a page in this book without any problem, and there's no formatting. It's all just free-floating text. I've been programming for years and years and years and years, and I cannot read my own programs if they're not properly nested. I can't do them as free text. There's something fundamentally different going on between this and that. And a lot of what people think of as the redundancy of natural language actually has to do with these little prepositions and noun phrases and verb phrases that are matching each other 30 or 50 words apart. They're actually doing that. They're creating the scaffolding so that you can read free text and keep the beginning of the sentence in your head, so when you get to the end, you close the parse tree, and you're doing this dynamically. Current programming languages are not designed that way. They're designed to be very efficient and very compact, and so they need to be formatted. So basically, we want to create this project, which we're calling Computationally Rich Emergently Operational Language, or CREOL. Our plan is to work with kids who are in a specific range of ages. They're old enough that we can work with kids who can see written word tiles. They started learning that, but they're not so old that they've lost the ability that we don't have to use parts of their brain to rapidly acquire language. So we're having them program in a graphic user interface, which is a variant of English, a subset of English, actually, initially. And the reason we're having them work with a graphic user interface is if a kid starts free typing text, the computer won't know what they're talking about. There are too many different things the kid can do. So by making a graphic user interface, we're not doing that just for the benefit of the kid, we're doing that for the benefit of the computer, so that we always have a dialogue between kid and the computer where the computer can say, hey, this is what I could understand next. You drag a word if up here, and oh, okay, that means you could put it there, there, and there. And it's a virtual game world with an English-like interface. In fact, many of the game scenarios that we're thinking of for the Rapunsel project, we're thinking we may adapt much of that infrastructure for this project, but when it comes time to what are the kids saying programmatically, it's going to look a lot more English-like. And we let them refine the language for us because this is something kids can do that we can't do, so effectively we want to exploit little children, but for their own benefit. Okay. And then the hope is if we do this properly, they will come up with constructs and idioms in the course of working with other kids to tell computers to do things that we can say, okay, this works for them when they're talking to something as limited and literal-minded as a computer in something that's intermediate between a context-free language and a context-sensitive language, and we have to find that space. They're creating the new Creole for us. So here's just some thought experiments, some little applets that to help you think about this. So here's a little 3D world. It's just a little 3D scene. It's like some nested things. It's much too simple. It's not the right kind of world. There are a lot of things about this that are wrong. But let's start talking just in terms of individual words. We're not going to build up language yet. So, we can have kids work with word tiles. And those tiles, they're fundamental things that you can do when you interact. Words interact with worlds. So, for example, you can assign meaning to assign values. You can ask what values are. You can change values. You can copy values. And you can always make a direct manipulation interface. So, for example, let's find out what the RGB value of this is. Okay, so it's like equal red, green, and blue. Then I could change this. This is just, this is not an especially like amazing interface. It's just one particular, I can copy this and, drop it onto nothing and it goes away. Or I could do the same thing with scale. I could say, okay, this is really skinny in X and in Z. And then maybe I can, keep copying that to a bunch of other things. And you get the idea. And if I dragged X, Y, Z up to this again, then I would find it has a new value. Or I can impart shape, I can impart motion. Let's say we want to bend this thing, maybe give it a little animation, spin it around a little. But now, notice that I'm doing all this manually. And this direct manipulation has some problems because I can't operate linguistically in a direct manipulation interface. I have to do everything one-off. I can't say, hey, for all the even ones, do this. Yes?
Are you trying to throw percentages and X, Y, Z coordinates?
No. I specifically am saying this is not what the kids would see. All right, yes, that's why I said that up front. This is not the thing the kids see. This is to talk to you about the concepts. Okay. You're absolutely right about that, and that's a very important point. So if I didn't say it explicitly enough, I'm glad you raised it. So, but now let's say that you have an interface where you have these linguistic structures built in, and I'll tell you up front, what I'm doing here is largely a Wizard of Oz kind of thing. I'm showing you some ideas about what interactions might be, but I don't have the back end of things parsing things. This is really just so we can think about these things. So there's some questions you might ask of the world. And notice that these are sentences, but they're also sort of these smart words that kind of want to fit together in different ways. So we can drop onto the scene itself a question, is any object moving? Well, yes, some object is moving. But in fact, if we say, hey, is the bottom object moving? Well, no, the bottom object isn't moving. You do a query into the world, and the world needs to be smart enough to be able to do things, answer questions, etc. If you drag onto an object, what's my color? It says, oh, this is my color. And absolutely, there's no way a kid would be thinking of a color as RGB. There would be some sub-interface that I haven't implemented anything like it yet that we'd work out. Maybe it's kind of red, it's kind of greenish, and, we learn about things like color mixing or whatever. Or maybe we say, what's my scale? So maybe it's really tall. And if I ask, is the object moving? No, it's still not moving. But now if I go here and I say maybe I should bend it a little and I should maybe do a little wave, now I say, okay, is that, yes, the bottom object is moving. I've changed something. It can do a query. The reason that this is interesting is that it starts to open the door for kinds of questions that you can't ask by direct manipulation. Properties about entire worlds, which are the fundamental things that start making linguistic reasoning interesting. The things that are the left of the other things, move them off the screen and then gather me up the ones that I told you before I liked. And so this is just, now, what we're going to end up doing in the actual interface is make the word tiles smart enough that they know about each other, that they proactively start saying, oh, there's a while statement, and if you drop the while statement in, it puts the other things in place and basically creates a correct grammar. So here's like a little art piece I made a few years ago, just because it sort of shows the idea of word tiles that kind of know about each other. So here, these words have magnetic properties, and they're all trying to sort of find the story they were originally in. So you can sort of blow them apart, and you can drag them. And if you do, the word alligator here, everybody moves aside. So we don't anticipate in our interface that the words would be as agitated as all this. But they would have this notion of background processes running and multiple threads running, essentially, that are saying, oh, this word wants to go on that word, this word doesn't want to go on that word. And it would be sort of a back and forth with the kids. So the interface would cooperate. So let's just discuss this and think about what the potentials are. So the key question really is what's naturally learnable? Because if it's naturally learnable and we put it in the context of the right interactive game and we expose kids to it, they'll learn it without, as you said, having to have this explicit adult supervision. And why not just use direct manipulation? Well, it's that whole linguistic thing. This is, there are arguments for, in evolutionary terms, why, as we developed into the particular kind of tool-using social creatures we developed natural language. The need for conditional ideas, iteration, symbolic reference, etc. For example, choose just the red and yellow ones. Or take away all the items that are bigger than all their neighbors. You can't do these sorts of linguistic tricks with direct manipulation alone. These are the kinds of ways of looking at your whole world abstractly and getting things to do things algorithmically that natural language was made for. So the early experimental work that we're going to start is going to test the fundamental hypothesis. And the fundamental is that children's linguistic acquisition skills can be utilized to develop a programming language that essentially all children can learn automatically, that will be learned by essentially, not the 10% which we call the math students, you know, the kids who like do the logo thing and get through it and are still interested. And our basic method is going to be to develop and then assess their proficiency. This is the first thing we have to do in directing computers to perform conditional, iterative tasks through the use of a GUI that makes use of their linguistic skills. If we can't figure out any way to do that, then we should stop the project right there, because either it's not true or we're not clever enough to figure out a path through. If we find that this starts to work with children in this age group, that's sort of a green light to move forward and start refining things. Now, it is about natural learnability. It's not, can we make an English-like programming language? But rather, can we make a programming language that is naturally learnable by children? The distinction is that the answer might be some sort of hybrid of different modalities. It might be linguistic. It might involve direct manipulation. After all, when I'm talking to you, I'm gesturing, I'm looking at you, I'm using body language. I'm using a certain kinds of direct manipulation that actually we have in common with other species, you know, gaze and gesture. And I'm using... and you really need gesture to make use of what linguists call deictics, you know, this and that. When I say that thing, there's a certain physical direct manipulation that lets you know that that is that and not that. The general conclusions here, because this is an abbreviated talk, is that if this works, if we figure out a way to do this and to redefine programming, then all of society may eventually be able to program and direct computers to do things for them, and ordinary people can get computers to do things. Now, I don't want to overstate this, because what we're going to do very specifically is only have them exposed as a naturally learnable thing, those aspects of computational semantics that little kids can learn naturally. So this means, for example, we're taking off the table some subset of what we think of now as mathematical reasoning. And we're going to say, okay, mathematical reasoning, a lot of it really kicks in after kids have already left the zone of natural language acquisition. That has to be, in terms of this, a more advanced skill. Some kids aren't going to get all the mathematical reasoning. An equivalent is, basically everyone in this society can basically sort of read or write. Some people go on and take expository writing and actually express themselves really well. Not everybody does. So there are some basic skills, and we can't be overambitious. We have to understand what's really in that first 7 years of what's naturally learnable. But if we can do this, then there's some interesting questions. When you have 300 million people in this country alone, or 200 million people, able to say to computers, oh, I know how to talk to computers. If you talk to them like this, they'll go off and do the thing that you told them to. They'll do things over the web. The little house cleaning robot will do things. The database search thing will go and find the ones that my neighbor likes but not my friend, that are smaller than this, and, you know, bring them to me. And then when it's all done, go and put that on my calendar. You know, hey, the computer can just do that for me. What will people choose to do? It would be really hard if you lived in a pre-literate society, in a society where people did not read or write, to understand and envision the social structures that would come out when you have near universal written literacy. A whole bunch of our society, the web itself, is predicated on the assumption that people can basically read. We couldn't even imagine something like that if the bulk of society couldn't do that. So, interesting questions. If this works, to any extent, how will society evolve? And that's pretty much all I have to say about that. So here are the interesting links to find out more about this stuff. Okay, thanks.
Yay.
Sure. Oh yeah, we want you guys to work with us on this, so that's why we're here. Okay. Yeah.
You talk about natural learnability and working with kids. Are you looking at learning models at all? Because
yeah, we got that phrase from our linguist and child development friends.
Okay, because in terms of the gender, like if you're working with 5 to 7-year-olds, do girls approach a computer differently than boys?
Well, the CREOL project right now really isn't focused on gender specifically, although my research perspective is that as we move in any direction, looking at what girls learn about can just kind of represent alternate ways of user, just a wider base of user stuff. But we haven't really we haven't split it out to gender or.
And I'm not sure that they do at that age, but is it something that you're looking at where?
Not yet, but I think it's a good idea to do that. And we have talked a little bit about that in terms of like different play styles and how like for example looking at how girls play house historically, the kind of playing with dolls and doll play, and how like kids playing together form a common language. One of the things that I didn't interrupt and mention, but Ken did mention that this may not be in English. It may not be an English-like language. It may have a lot of gestural, drawing kinds of things. It may also be. I make up a lot of words, and I can't help but think about kids sitting together and saying, give me the thingamajiggy and the whatchamacallit, and like these things have these shared definitions or these shared kind of variable states where like right.
Yeah, it's true. When I talk about English-like stuff in France, they get all weird. It's not as bad as Montreal, but I do. My take on this, though, is that when we talk about the word underrepresented in the context of the Rapunsel project, we're largely talking about a gender gap. When we talk about underrepresented in the context of the CREOL project, when you're talking about what can you get people to know how to do, by the time they're 7, you're talking about a much larger gap, which is an almost everyone in the population gap. So I think that actually dwarfs gender differences at that point. I mean, over 90% of the people in this society don't really do what we would consider programming. And most of them think, I never could. So that's a really interesting transformative problem. I wouldn't want to cast the 5 to 7 thing as a subset of a gender problem, because I think it addresses something else. Okay, yeah.
So to tie into the making language up thing, how can kids add their own vocabulary into the system, or what is the process for refining the vocabulary of the system? In the example you gave of natural language, there are words that are made up, or phrases that are made up, or meanings that are made up constantly, and do you have the capacity to capture that, or use
we
that?
Actually don't know. We're thrashing about on that question. We're talking to, there are some people interested in starting to get involved with the project who are machine learning people who are really interested in trying to capture when the kids are doing something that has an operational significance, and then they're using things together, and to see if we can get the system to discover when idioms are being formed. But we don't know how successful we'll be.
Or even if there's some feedback where the kid can say, that didn't do what I expected.
Right.
And are you considering those sorts of systems where they can provide that feedback into a system?
Yeah, we'll do everything we can. I mean, at this point, we're just going to try to build the initial version of the system. And one of the first things to do, I think, is to see where the kids are frustrated and listen to how they're frustrated and what they're saying, and then see, what do we do next? Do we put little picture tiles that aren't words yet, or nonsense words, and let them put those in and see what they do with them?
Yeah.
I don't know. There are a lot of possibilities, and some will work and some won't. Yeah.
My understanding is that you enforce stereotypes in these games, but I also can't help but think that you're going to be more successful if you do play them a little bit. Like, for example, girls are more social or more socially oriented.
Yeah.
And even in these demos that Kim was showing, you're manipulating an object and interacting with an object. And the girls are going to want to be interacting with live beings that are interacting with each other.
I just want to point out that in my defense, there is no question that this is not the world that I would use. I basically wanted to talk an initial audience through some linguistic concepts and how the words map to things. I mean, I was heavily involved in the little characters running around. So, I'm a real big believer in you got to buy into the character, and then, we're all interested. So it may have been the miscommunication if in any way we implied that that's something the kids would see in terms of the world. You're absolutely right. We wouldn't go in that direction.
The first, and to go further on that, the first thing that we're doing is building, and maybe this is an interesting part of the iterative process. We built systems where kids could control their own character, like a little pet model, and we are moving towards alternate models, like a team model. Maybe you have a team of pets, right? So then your team can help another team, or you can swap team members. That's one model that we've been talking about. One of the reasons we haven't done the multi-user testing first is that it just takes more time to build that prototype back end. And so we thought we could get a lot of at least art style and concept, and like some interaction style that isn't social. But I think that we've hit that place where we can't do that anymore, where if the number one criteria, well, we have two main criteria that are driving all the design from this phase forward, which is it social, and and are they programming? Just, that's it. So for example, we have this really cool idea where it's called, I have to tell them about the 10-second trauma thing. So we have this, one idea is like you have this 10-second trauma. So you make a little movie with these little characters. You get a little, kind of like a 10-second thing where you tell something that happened that day. So, because if you go home and a lot of kids are working on computers after school in a library or whatever, you tell a story of social interaction, what happened right after you experienced this. So, oh my God, I saw this person in the library and they said this to me, and whatever happened, you act out that kind of social situation. You post it on a blog-like system that we would develop, and then other people can hack, they code into your story, and they can change the behavior of different characters. So, and then they post their version of your story. So this is what I thought happened, and your friend says, oh no, that's not what happened, this happened. And then your worst enemy can make you look stupid and put this hat on you, and all those versions are equally valid, so that there's this kind of dialogue between them, and it's kind of taking advantage of blog culture. But the one problem with this idea is that really, in our initial sketches and things, the programming is not fundamentally metaphorically tied into the structure, and so we kind of I may just make it with my students anyway as a side thing, because it's really interesting. But I don't know. But that's, so we're running in it's not just.
Social rules and social games,
Yeah.
So they're interacting with a set of beings, and they're making these rules, and then the beings break the rules, and they can be very upset and, interact with it in that way. So that is programming in a sense, where we're creating these rules for a set of people.
Yeah, come on.
We need somebody.
One other thing, then we may throw this idea out at the end, but it was initially important to me, based on the other project, and working with the kids that we're working with, to actually teach them an existing programming language. This has brought up the CREOL project, which means that, okay, the existing programming language isn't necessarily the right thing, but also, if you're a kid and there's no computer science class in your high school that you're going to, if you can say, hey, I know a little Java. If you could say that carries a lot of cultural currency.
Two of the fundamental things about projects like the Logo project, which we've been sort of iterating against. In some ways we're doing very similar things, but in two very specific ways where we've made different decisions, is number one, rather than it essentially be a low-level math world, it's already a relatively high-level social world where there's already engaging characters and interesting things going on, so there's a story that you're walking into. And the other thing is that a lot of people who've been through that program, they learn Logo, and then they get good at it, and then, they get to about third grade or fourth grade, and then they drop it, and it has nothing to do with their adult life, and they don't see their older brothers and sisters doing it. So we felt it was very important for the Rapunsel project, where you're talking about 12 and 13-year-olds, that whatever the language is, it's a language that their older brothers and sisters and people who are in the computer science, I'm really programming world, are using.
Or maybe they'll see a class, at a community center. Hey, I know something about that. So that's.
But we don't have that constraint with CREOL, because it's just serving a different purpose.
It's different.
So two questions, because you brought up one. But first of all, the kids that you've taken this out to already, are they excited? Are they sort of manipulating it on an ongoing basis? What they've seen so far, in terms of Holly's world and Rapunzel stuff?
Right now, it's not persistent yet. It's not persistent online living there. Yes.
Okay. So second question is.
But that's the plan.
Okay. We in the Northwest, doing sort of Microsoft's way, live in a really privileged world.
Yes.
My kids are so overexposed to programming and software engineering, etc., they don't think it's cool. There's sort of this nerd image. Is that true among the population that you're working with? I mean, it's not a positive.
I don't think that, I'm going to just say something, I don't think that there's a place on this planet where programming is cool, except among people like us, okay? I'm just going to say that. Like, it's just not culturally
We
cool.
had our moment with war games, but it was almost too bad.
Yeah, that was not cool to most people. It's not cool. It's so funny that you say that, because you would think, like, here in San Jose are like the two places where it might possibly squeak by as being slightly cool, and it's not. It's really not cool. I mean, it's so not cool, but, so we're not going to call it programming, first of all. We're not going to use the word code. Coming up with, like, they're speaking a secret language, and you're trying to figure out their secret language.
One thing that came up this morning was that all these large number of people who program in Excel and don't even know they're programming.
Then it's okay.
It's just not culturally defined. Oh, no, I'm doing a spreadsheet. I'm looking at, oh, that's cool. I'm making money. And then people who use Macs.
Yeah, okay, let's go
music
through.
patches. I'm a musician. I'm an artist. And of course they're programming, but no, they're not programming. And it's, if you have a programming environment that's designed for some purpose, and it's all about a purpose that that person in their subworld thinks is cool, and they're living and breathing that purpose, that's where they are.
And there's one overall game example that's a smaller game than the game we originally envisioned as a multi-user game space, but it may match this, and this is what we're testing right now, is a dancing game, because choreography is about control, and it is about kind of scripting, and you do have to, and even, you could even get into Laban notation and some kind of very crazy maps of this stuff, but that's one place that we found that kids respond to. They can pick their own music, can you match the beat, all that stuff is really, people in our demographic are really responding to. The question is, in what ways is it social without being competition-driven only? Like, can it be cooperative and competitive? Where is it cooperative? Like, what are the motivations for swapping the dance moves? I personally, it seems like a smaller subset of what the larger world that we're trying to build, but it does match both of those two. It's a little weaker on the social, but it does match the programming goals.
Well, I mean, and there are ways that we've been looking at what other people have been trying to do. So, for example, you have a dance game. Competitive is, I dance better than you, I get to go to the next level. Cooperative, if you and I both get to do the right dance together in the right way, because I program mine and you program yours, we both go up to the next level together. So there are ways of taking the same activities and making them not, I live, you die.
And then also, rewarding creativity is something we've talked about a lot in our group. Like, how, it seems really arbitrary how you reward creativity, but it's something that a lot of game designers just stay away from, because it seems like such a loaded thing. What does that mean, creativity? Is it the number of clicks and how long you spent in your little room making this thing, how tall your hat is on your character? I mean, what is that? But we're trying to come up with some kind of metric to make up some arbitrary reward system that is a creative reward system, so that we can appeal to the ultimate game goal.
You have a question?
Yes.
Oh, sorry.
We're both pointing in different directions.
Should we? You want to say something?
Oh, I was just going to respond that it seems like, well, and the reward for the creativity aspect, I think, really does come from the social scenario, right? Because like if you put extra work into how you dress when you go to school or whatever, I mean, the reward comes from all the other people who respond to that.
Yeah, and the social ranking, you can have social rankings. But then the it is very misshaped.
It's a great try to put the effort.
And we'll give you a high score for that. It's the whole social community, but there's also, in one of our scenarios, I came up with this crazy little magazine that looks for the least popular people and the least commented people and highlights them, right? So it's like, I have to root for the underdog, right? So I have to the people who are one friend on Friendster, who are they? And let's meet them, all those people. Those are the people, I don't want to forget them, so.
So what was your question?
Okay, you raised the issue of diversity before. Now, if you didn't know the names, would you be able to tell whether Fortran or Cobra or Ada were done by a man or by a woman? If you know the name, of course you know. But from the reference manual, would you be able to tell?
Well, it's interesting, in retrospect, of course, we know Grace Hopper's whole philosophy of trying to make it like English, although it was an early phase. So COBOL has the intent. And so...
You have to give you the credit.
What?
just gave it to the crypto. And after the
Oh, I'm sorry, I was supposed to keep this secret? No,
I thought I told you. Who knows in the room? No problem.
I guess, I want to take that up, because I think that too often we can look at examples like, okay, well, a woman was involved in this project, so therefore it has to have, there's equity involved. There's a sense of that, or even if a woman designed a computer programming language, and I'm a designer and I'm participating in this stuff pretty actively, and I wouldn't necessarily say that every single product that I make is like the representation of the ideals of diversity. I don't think I can say that because of how I've been constructed as someone who makes stuff in this field, but I think I can, through this reflection and all this kind of stuff, try to take steps and try to get a lot of outside opinions, because that's something that we're really committed to trying to do in our group, and also talk to people from the more like economically diverse. That's why I'm really surprised about the geek thing, because it's interesting. We're not dealing with a demographic of people who already have access to this stuff. We're really dealing with another group, so it's interesting. You guys have
a couple of questions, items. One was on cooperation. Is cooperation always mean multiplayer? Because when I watch my friends' daughters play with their Game Boys really happily, they hated Grand Theft Auto, loved Game Boys, they play individually, and then they'd be comparing. How'd you do? I don't know. Yeah, how do I get the next one?
Yeah, this is really quite like the pair programming model, or some kind of. And a lot of the times when we're doing testing, kids do pairs and they get together and they will solve problems together if there are not enough computers. I actually like to teach this way. Like, I prefer to teach it if my university is poor, so that we have like half the number of computers we need, because then people have to talk to each other, and in fact they start to talk to each other. Oh my God, which is kind of refreshing on a college level. But one thing, we can't control that. So for this project, we're trying to define social as some kind of exchange online in between people who aren't connected. Whether we can also foster an in-person collaboration, that's good. But we can't count on that, because then we start to think about after-school programs and how are we facilitating. We don't have control over the context, but we can try.
And so what I was getting to was that cooperation might not always be simultaneously linked. It could be posting, it could be chat.
Oh yes, like sharing the boards.
Posting back,
Yeah, it doesn't have to be live collaboration, and also it doesn't necessarily. We've also thought about. Who wants to be forced to collaborate? Like, hate, yuck, right? So there have to be goals that don't require you to talk to anybody. If you really want to do this thing yourself, we have to allow people to do that as well. There are a lot of people who don't want to rely on people. You might get along you might get much faster and much better if you get advice from other people and all these things, but if you choose not to do that, you still have to be able to play.
Other question was general advice for kids who want to learn the program. I have 4 nephews, and for some reason one, and only one, he's really interested. He's got in his head he wants to learn the program. He's 10, 11, and he just wants to learn this. And I'm trying to figure out, where do I start with him? And I would love to plunk him into something like this to go experimenting.
Send him to Ken's homepage.
Okay.
And have him email him. That's what he does with his relatives.
There was a great exhibit at the National Academy of Design over the holidays, where they had industrial design, but it also included a few site-specific works. You'd run up and down the stairs, and depending on the volume of people who ran up and down the stairs, flowers would swirl around this 15-foot tile screen in response to volume and direction. He just stopped in his tracks and said, what is it, how does it work? And as I explained, he said, I need to know this.
Oh, you know what I was into was Robocode. Robocode? Mindstorm.
They actually need to do a robot.
Robocode is a really nice little where you build these little robots to fight. It's smart. It's a smart little system, and it's an online system. It's Robocode.
But
anyway, I'll give you more.
But your agency is putting bits of code inside of them. So you learn.
You code.
Yes. You code.
And you can, it's like a little, you simulate these little robot war
We
things.
probably have time for just one more question.
Okay.
I know you had a question.
I had one. Have y'all looked at the level editors and maps and mods? Because it sounds directly parallels.
Yeah, in fact, we actually think that one of the possible things that's going to happen as Rapunzel matures is it's possible that it's going to take on more and more aspects with appropriate scaffolding and, training wheels.
The next version looks a lot like the Unreal editor.
Yeah, it's going to go. One of the differences, for example, between Rapunzel and a level editor, there are a lot of things that we'll probably have in common, but one thing that's going to be a big difference is that we're going to really need a smart editor. We're going to need the editor itself because of the script editor.
Well, it's got scripts in that.
No, I mean, like, not letting
It's
you
not
hang
smart,
yourself.
though. It's not very nice, the Unreal Editor.
No,
Like,
it's not nice.
Well, that's what I mean. It's going to.
That's actually what you're talking about.
You can't sort of, the whole thing falls apart because you left out a brace. So we're going to have to build a kind of infrastructure, but in many ways, yes, there are similarities between what we're talking about and
the room behavior and direct, right?
very good point,
similar.
yeah. And we're looking at level editors, although we have to write something appropriate for 12 and 13-year-old girls, but yes.
Well, just one final comment is that Ken and Mary are both here tomorrow as well. So we have a very action-packed schedule, as you can imagine, but there are 1 or 2 slots open. So those of you watching remotely, if you have an interest in this and want to talk about it in more detail, or any of you who are here, just email me, Johnsang, Johnsang, and I can carve out some time on their schedule. Please join me in thanking them for their time.